Okay, folks, I'm just going to go over a few of the most commonly missed Khan Academy problems from last week. I just went through each problem set and the quiz and took a look at what was commonly missed on the first try between all of you. Also, just a heads up, I've assigned all of you the same problems except for the quiz. So if you ever want to work together via like a Zoom or a FaceTime or something, you should be able to do that because the same problems should come up for the problem sets for you. All right, so here's the first one. I saw a few specifically where you had to use the fundamental theorem of calculus part 1 and the chain rule that seemed to be confusing people on the first try. So in this case, they give you this accumulation function, capital F of x, and they want to know what f prime is, meaning the derivative of this. So before I do this, I'm going to go over this in the way that I kind of talked about in my FTC1 video, which is I like to not worry about what the actual math of the or the expression of the integrand is. Just think of it as a function. So the integrand is root 15 minus t, but that's not important right now. Just call it g of t dt. So the fundamental theorem of calculus part 1 says that if then I take the derivative of the accumulation function, what I end up with, as long as my lower limit's a constant and my upper limit is just x, I would end up with the integrand as a function of x, right? But in this case, what we need to remember is that it's not exactly set up perfectly for the fundamental theorem of calculus part 1 because my upper limit is not just x, it's actually a function of x. So when I do take the derivative, I'm going to use the chain rule. So I'm going to do the derivative of the outside function first, and the outside function being the integral, which is going to leave me with g, but instead of x, it's going to be g of 3x. And then I say times the derivative of the inside function, the inside function being that 3x, so ddx of 3x. All right. So then I have g of 3x times 3. And now I can worry about going back to the actual expression for my integrand, which was this root 15 minus t. I called that g of t. But now I'm just replacing my t's with 3x. So what I end up with is root 15 minus, instead of t, 3x. And then I have that times 3. I'll just put that in the front. And there's my final answer. All right, let's try another one. Same idea here. Okay, we're finding f prime again. I'm not going to worry about the fact that that's 2t. Let's just call it g of t. So now capital F of x is equal to the integral from 0 to root x g of t dt. So f prime, I'm going to do derivative of the outside function, which by the fundamental theorem of calculus will leave me with g, because that just undoes the integral. But instead of x, since my upper limit was root x, my upper limit is its own function, it's going to be g of root x times the derivative of root x. Remember, root x is x to the 1/2, right? All right, so what am I going to have? G of root x times 1/2 x to the negative 1/2. And I'm going to go back, since this was g of t, and now I want g of root x, I'm just going to replace the t with root x. And that's going to get me 2 root x times, now I'm going to simplify that 1/2 x to the negative 1/2. That's really times 1 over 2 root x. And so this one's kind of clever because these things cancel and I'm just left with 1. All right, moving on. Another one with the chain rule. I think this is the last one that I pulled with the chain rule. I know these are challenging at first because you're not used to seeing a function of x where x is the limit of the integral. So it just takes a little getting used to. But you just have to remember that x is our input and x is our limit, right? So if x is anything other than x there, you're going to have to use the chain rule to differentiate it. So same idea here. Let's not worry about this for now. Let's just call it g of t, so that f of x equals the integral from 0 to x to the 4th g of t dt. Now let's find f prime. So derivative of the integral just undoes the integral, and that's going to leave me with g of, instead of x in this case, my input is a function itself, so x to the 4th times the derivative of x to the 4th. All right, and now we'll go back and replace g. G is cosine t, so g of x to the 4th is going to be cosine of, instead of t, x to the 4th times the derivative of x to the 4th would be 4x cubed. That's it. All right, a few other types of problems. So this was interpreting an integral as geometrically as an area. So find the integral from 2 to 5 of f of x dx and give it as an exact multiple of pi. 2 to 5, you just have to be careful that you're looking at the right region. So that's all region that is below the x-axis. And so what we have here is a quarter circle. Okay, and we know that, right, area of a circle is pi r squared, so area of a quarter circle is pi r squared over 4. And the radius of this circle is what? 1, 2, 3. And so my area is going to be 9 pi, because I'm plugging 3 in for the radius, over 4. But again, since it's below the x-axis, or the t-axis, I guess in this case, we're going to interpret that as a negative area. So your final answer should be negative 9 pi over 4. So the integral 2 to 5 of f of x dx equals negative 9 pi over 4. All right, let's do another one. Okay, for this one, we want the integral from 0 to 3 of f of x dx. Again, we're just looking at negative area here because we have all this, right? So there are a couple ways you can do this one. I'm going to say let's break it up into separate pieces. So like I have this triangle, and then I have this triangle, and then we have a trapezoid in the middle. And again, our final answer is just going to be negative because this is all area under the x-axis. So for the bigger triangle, so I'm just going to do negative. For the bigger triangle, what are we going to have? Half base times height. Well, the base seems to be about 1. The height is 2. So half 1 times 2 plus, let's see. So for a trapezoid, the formula is half, it's height over 2 times base 1 plus base 2. The height is the distance between the parallel bases, so the height would be this, which is 1, 2. So it's 2 over 2 times the length of base 1 plus the length of base 2. So base 1 is 2 plus base 2 is 1. And then for our last triangle, half 1 times 1. So plus half 1 times 1. Close that out, and then I already have that negative out front to make sure I interpret my final answer as negative. So I get 1 plus 3 plus half. So that's 4.5. So 9 over 2. So final answer is negative 9 over 2. All right. This next one I chose, this was, I think, from the quiz, and since it assigns you all there, it chooses from a test bank of 90 different questions, so very rarely are you guys getting overlapping questions. So only a couple of people got this and missed it, but I liked the type of problem and I wanted to explain it, so I just threw it in here. All right, so g of x is equal to the integral from 0 to x of f of t dt. So g of x is an accumulation function. And it asks, what's an appropriate calculus-based justification for the fact that g is increasing? So we know g is increasing because one thing to note is that this is a graph of f. So they're showing us a graph of f. So remember, to discuss whether a function is increasing or decreasing, we can look at its derivative. So in our case, g prime of x, by the fundamental theorem of calculus, would just be f of x. We'll note that that function is all positive y values. So I can also say that this is greater than 0 for all x greater than 0. And since g is only defined from 0 to x, I only really need to worry about the positive numbers in this case. And so what we've said is that g prime is positive, therefore g is increasing. And it's just called the ID test. We learned it early on, but the increasing, decreasing test, meaning looking at a function's the sign of its derivative tells you where the original function increases or decreases. All right, last one. Accumulation function, let f of x equal the integral from -1 to x h of t dt. Evaluate f of 4. So f of 4 then equals the integral from -1 to 4 of h of t dt, which is then going to correspond to the area under this curve between -1 and 4. So here, all the way to 4, so to here. I want to look at all the area, and I'm just, again, this is all above the x-axis, so it'll all be interpreted as positive. I'm going to break it up into 2 sections, right? We have our rectangle, and then again, we have a trapezoid. All right, so let's do it. The trapezoid is going to be half the height times base 1 and base 2. The height is the distance between the parallel bases, so that's a height of 2. So half the height times base 1 plus base 2. So base 1 is 6, base 2 is 8. So 2 over 2 times 6 plus 8 plus our rectangle is just base times height, so has a base of 3 and a height of 8. Plus 3 times 8. All right, so what are we going to end up with? 14 plus 24, so 38, final answer. All right, guys, I hope this is helpful. Hit me up if you need to meet or need me to record any more videos. Hope you're doing well.